is provocating enough today, then we might have a chat. If it's provocating even too far, then just ignore me. That's also okay. But I'm very happy to be here. I've worked with Martin a lot on kind of proxemics and distance and virtual reality and augmented reality. But today I'll talk about something very different because, well, AI is where the funding's at, right? No, just joking. So today I want to talk about metacognitive challenges in human AI interaction. And the agenda for today looks something like this when the clicker is working. Oh, that's the problem. Okay. Anyways, so the agenda for today is I'm first going to talk about our research that we've done on the placebo effect of AI technologies and how kind of placebo effect of AI hampers with evaluation of human AI interaction. And that's maybe to give you also a little bit of a tool set maybe to do a better evaluation of AI systems. And then I want to also talk about kind of within these studies on the placebo effect of AI, we found a very weird pattern of data where people overestimated their performance. And that's what then fueled a little bit of a research program on metacognition and human AI interaction. And I think that's kind of, and I wanted to keep it narrative today about kind of like how we went from one part to the other, because it can like highlight how you do a little bit of a research challenge and how we move on from iterative testing and experimenting towards a new research paradigm. So let's first talk about human AI interaction a little bit and the placebo effect. So I want to talk with three premises. So first of all, we're all working a little bit this human-centered design process, and we probably all agree that most of the technology is at the end made for humans, right? So technology is made for humans. That's the first premise. Second premise is that people have very high expectations around AI technologies. So we all see this AI hype, and on average, we all now very excited about what AI will do with our lives, right? And this even gets to very absurd kind of levels when we look at kind of what Sam Altman and also Sundar Pichai say about AI. Like he says, Google CEO, that this is bigger than the invention of fire. And Sam Altman basically says it will solve all the problems in our lives. And if you listen to those people talking regularly about in some of those weird podcasts, right? They really create some urgency and high expectations in us. Maybe not in us, but I would say in general society. Policymakers, lawmakers, yeah, and my mom, my grandma, and my grandpa. So what we know is expectations, high expectations can produce placebo effects. We know this from medical research, right? A sugar pill that you give someone can alleviate subjectively your condition and even make your symptoms kind of go away, right? So we can get subjective improvement from a medical treatment that is non-functional, a sham treatment. So we asked ourselves the question, can the same thing work also in human AI interaction? Can the high expectations that we carry around AI actually produce us to, feel like we perform better and also make us perform better? So we set out on a journey to figure this out. And the key concept here is we present participants with a non-functional AI system. So we just label something as AI and make it kind of, make it graspable that AI could be in the mix there. And we compare this to a control condition and then see how they evaluate the system and also how they interact with it. Why is this really not working today? Good. So in this study that's in Tokai, and that was even before ChatGPT came out, so we had kind of very old school AI where we said, we have either an adaptive system or a non-adaptive AI, a non-adaptive system. So in one, there's AI. In the other, there's no adaptation happening. You're solving word puzzles in both of those conditions. And in the one where the AI is happening, the puzzles are adapted so that you perform better, right? So we had those two conditions. None of the AI technology was functional. We only labeled something as AI. Everything was kept the same. We did this twice, actually, and replicated the results again. You can see this in the paper, but I'm going to show you the very simple study that we did in a within subjects design, where we had people first try the non-AI condition and then the AI condition, and the other half of the participants obviously did the reverse, so everything was counterbalanced. You see, kind of, I'm an experimental psychologist. I care about trials, conditions, and so on. So what we did on the measurement part, because experimental psychologists also care about this, we first asked them, how do you think you will perform in this one condition as compared to the other before they encountered the condition? Then we looked at their performance when solving those word puzzles that we gave them. And then afterwards, we also asked them, did you perform better in the one condition as compared to the other? And what comes out of there is, first of all, we could show, first of all, that we can induce those very high expectations. So not only Sam Altman and Sanat Pichai are very good at creating AI hype, also we're good at that. So that's great. So then when we looked at their performance, we could, first of all, not see much big of a pattern. Both groups were kind of the same in terms of word puzzles. But what we saw that afterwards, after doing this, they believed they did better when they used the AI system as compared to the no AI system. So their expectations, they were leveled a little bit because the word puzzles were tough, but they still believed the AI condition made them perform better. When we now looked a little bit deeper into the data, we found quite an interesting pattern. So if we combined kind of those expectations, the individual variance here, you see there's a lot of variation, and then correlated this with the individual variation here, then we could already see kind of what we now see in society a little bit, namely that those that are AI hyped, so that have very high performance expectations, that they also perform a little bit better. So first of all, we need a lot of kind of a very harsh introduction. We need to create a lot of AI hype. And then we also need a good measurement device. So here, our measure was not maybe perfect. So what we did then in the next study is we improved the measurement side, and we also looked a little bit deeper into the hype side. So how much expectations we bring in. And this is a Kai paper from 24, where we had a much more granular measure of performance. And people, I'll show you, but they had to do a reaction time experiment, so very cognitive psychology, where they saw letters and then had to discriminate them. And then we said, again, AI will help you. Or even we had a negative description of an AI system as well, where we said, well, the AI may actually make you perform worse. So, and then we had an AI system, a non-functional AI system labeled, and a condition where participants thought they had no AI at their hands. The experiment looked something like this. So now very cognitive. They saw a letter in the middle, and then they had to rapidly discriminate whether the letter is the same as to the right side or to the left side, classical letter discrimination tasks, and we can measure reaction times and percent correct in there. And with this, we actually managed to also find because this is a very granular measure of cognitive performance, we could actually find that when you use the AI system, so the non-functional AI system, sorry about that. So when we said people are using the AI system, either it didn't matter that it's positively described or negatively described. In both cases, they got a little bit faster and a little bit more correct. And the thing is, this was really 200 trials. So they're kind of, and we had a large data set. We used Bayesian analysis to verify everything. We modeled this even with a drift diffusion model, which is a classical model from cognitive psychology, to estimate kind of the trade-off between correctness and reaction time. We did everything to show that this is robust, and really could then show that the system description, whether we frame the AI system that was non-functional as positive and helping, or as kind of not so well designed, this did not affect the data too much. And this was kind of puzzling. Again, keep this in mind for the later discussion, because we can resolve this puzzle later on. But what we should summarize right now is we can not only see a subjective effect of a sham AI system, but also a behavioral effect. So you can really see this in the reaction time and correctness data of people When they think they have an AI system at their hand, they get a little bit more correct and also a little bit faster. So I just want to bring up the point now that the placebo effect of AI can therefore fundamentally affect our interaction patterns, not only subjective, how we feel we did, but also how we're actually doing this. And there might be actually consequences to this. So what we did in a third study is we asked ourselves, can this then affect when we think we perform better and we grow and we are cognitively augmented by some system? Can this actually change how we take risks in risky decision making? And in this study, we had a very crazy setup, but it was very much worth it. And we're going to run you through this. So we put an EEG cap on people. And with the EEG cap, we can measure a little bit of brain electrical signals of the scalp. And typically, we use this to infer rapid information processing. And we had this EEG headset and told participants that the EEG headset is actually a BCI technology, so a brain-computer interface, that is hooked up to a speaker, and the speaker plays an inaudible sound. So that this sound will modulate their cognitive performance so that they are better at making decisions. I do not know how they believed in this, but we made this very, very apparent, and we obviously ask after all our experiments if they truly believed in our setup and so on, and we do an analysis with the believers and without to show that there's no difference. You can look this up in the paper. So we're taking a lot of precaution here. But anyway, so the sham system is, we have an EEG, it's hooked up to a computer, and there's speakers that play inaudible frequencies to the user, and they think this augments their perception. So there's kind of like a very BCI AI technology here. But what you actually do is we don't do any adaptation and any BCI stuff. We only record the EEG signal while they're actually interacting with the task. Whether they think they have an AI system or not. Again, we do a within subject experiment, and here the task looks something like this. Here they have a Columbia card task, and they see the cards shuffling, and they see kind of where there are error cards and there are cards that are win cards, and they can engage in risky decision making, flipping more cards open, then they get more points, and if they stop, they are a little bit more risk averse in the task, because then they are less likely to encounter an error trial. So we did this, and the interesting part here is, first of all, we find kind of the subjective effect. Then we find the behavioral effect, not on the main effect side, but rather on this interaction again, when we have high expectations around the system. So when they really believed in the story we told them, then they also take more risks in the risky decision-making task. Kind of makes sense. But what we then could find out when we looked at the EEG recordings, and that's the interesting part, we looked at their kind of P300 signal, which is a signal in the EEG where you integrate novel information. And typically when you lose money in such a task, you would have a spike of this P300 because you lost something, and you would integrate this information in your thinking. But what we found is when you think you had the AI system at your hands, you integrate information less, and the P300 was lowered in this case when you were on a loss trial, as compared to a loss trial when you didn't think you had AI on your hands. So what I just want to bring about is the point that the placebo effect of AI has some kind of effect on information processing for risk-taking. So it might be actually that you do think that you're augmented and take more risks, and you do not learn from the errors you do. That's just very anecdotal right now, and we need to do more research on this, but the evidence starts to accumulate on this area. So I just want to take a little bit of an interim conclusion, because now we only talked about the placebo effect so far. So descriptions of AI technologies can produce a placebo effect on 3 levels. We saw something on the subjective level, we saw something on the behavioral level, and even if you then say you do not trust me, or you do not trust in a placebo effect of AI, we saw something on the physiological level. What we also could see is that high expectation can have real consequences of taking riskier decisions in kind of economic decision-making tasks. So what I want to ingrain right now into your brain is that if you have any descriptions of AI, think about the hype and what this will do to your evaluations. Because people might not really see the technology as it is, but rather only subjectively evaluate the hype around it. And I've thought about this for a long time, why this is the case and why this is so persistent and why we could even find these effects so easily. And then I came across this thinking that there's some weird pattern in our data, actually. I showed this to you in the first experiment already. Namely that after doing those interactions, you do not realize that there's a sham system, that it's non-functional. We found that people still believed after, in this case, I think 40 trials of solving word puzzles in the first experiment, that they still thought they performed better when they had the very non-functional AI system at their hand as compared to the controls. We find the same thing for the EEG study. Again, that there's kind of this sham treatment leading to overestimation of performance afterwards. And we also find this for the study where we had this very granular measure of reaction times. And actually in this study where we had kind of this reaction time task with the letters, we had in each condition, I think 200 trials. So after 200 interactions, they still did not realize that the AI is not supporting them properly. So I was thinking very, very much about how can we understand this, that even after interaction with a non-functional system, you do not get it. You do not realize that something is not really working and not really helping you in any way. And here kind of then came the idea into place that we have to think about human metacognition. So how we think about our own thinking. Human metacognition is something that we use in everyday life to regulate our cognitive processes. So, for example, if you're in front of an exam, you use human metacognition to understand, okay, have I learned enough, or do I still need to learn more? Or I would be using this to think of, okay, right now I feel very exhausted, so I should take a break. That's something metacognitive because I think about my own thinking. And if we bring this to human AI interaction, it's kind of like, how did I use the AI and was this effectively? And I think there are some ingredients in the way we interact with AI that make our human metacognition very bad. And I want to show you with another study how our human metacognition might be clearly disrupted when we use AI systems to gauge cognitive performance. So we asked the question is, can people monitor their performance in human AI interaction? Do we actually monitor what is going on when we use AI systems? Do we understand that this is now an effective interaction or this is not an effective interaction? And we did this in a way that's what was very standardized. Any of you have been to the US and taken the law school admission test, the LSAT? It's a classical test that a lot of people in the US go through because it kind of it's a benchmark exam to see whether you can go into law school. And in there are basically just logical reasoning problems, and they've been used all over cognitive psychology to understand, first of all, how good your cognitive performance is in problem solving, and on the other side, also to understand how good your metacognitive performance is in estimating how many of the problems you actually solved right. So what we did is we gave people those law school admission test questions and asked them how confident they were and had them either complete those law school admission tests with AI on their hands or not. This time we have functional AI, so just GPT-4 they had on their hands. And what we find obviously is when they do those tasks and they use AI, they do get better cognitively. So while normally people solve about 10 of 20 questions here, or 11, so that's kind of the mean here, when you have ChatGPT on your hands, we are more in the domain of solving 14 of 20 questions, so like 70%. And many of the people are even, like most of the people are very close to the performance of ChatGPT alone, and only some of them are much better than GPT. And you can see those here, right? They're disproportional in terms of, so there are some people who actually use the technology very effectively, apparently. But when we look not only on the cognitive performance, but when we look at their ratings, how well they performed. And here in this task, we could just ask them, how many of the 20 problems did you solve? Then we can plot this cognitive performance that they had. So they achieved LSAT score from 0 to 20 and can map this onto what they estimate. If they are good at estimating their own performance, right, they should be here on this line, right? Perfect metacognitive monitoring of your own behavior. So if you really know and you're really aware of your performance, you should be somewhere on this line. If you're a little bit skeptical, right, you should be here, right? You underestimate slightly. If you're totally overestimating yourself, you land in this territory. So I might ask you the question now, if you're really hyped about AI, where do you find yourself? We would find a lot of people here, right? And if we do the task and people use AI, well, some of them, they perform very well, but we see kind of a large proportion of people overestimating themselves. And if you only look at the mean, then we can see that compared to kind of a better than average bias, so everybody thinks they're a little bit better than average, right? This is why we are a little bit above the line here, typically when we have no AI. But when we have AI out of our hands, this gets disproportionately large. So it's not only better than average, but we think we are superhuman when we use AI systems. And if we ask, for example, what's your percent rank in your sample using AI? The mean should be 50%, right? Because, well, if you have a percentile distribution, the mean should always be 50%. But what we end up with is like something like 70, 75. And in the no AI condition, we're at 60. So there's only slight overestimation typically, but with AI, overestimation gets proportionally big. But what we can do is we can also look at individual variance here. And you might already have kind of, if you've taken like a Psych 101 class, you might have encountered actually some graphs like this. Anybody of you have heard of the Dunning-Kruger effect? Yeah? Anybody wants to summarize it so I do not have to? All right, I'll do it. Anyways, so the Dunning-Kruger effect basically says that people that, and I'll now do the scientific one, not the pop science one, people that are low achievers in a given task overestimate their ability relatively more than the high achievers. And we can do this, we can look at this more granularly if we do a quantile plot. So we can look at the performance quantile, first quantile of performers, second quantile, third, fourth quantile of performers, and then compare this to the average score and have the estimated and achieved thing. And what we would typically find in a typical Dunning-Kruger example is we see a spread here, but the high performers, they're kind of good at estimating themselves, while the low performers, they're off and they're overestimating themselves proportionally worse. So kind of, this is not really what we find for the AI group here. And this kind of plot here is not the perfect plot to use, just so we've talked about this, and you can read this up in the paper. This kind of plot, if you use quantiles and so on, we have the regression to the mean, the statistical modeling of then comparing those data points maybe with a t-test and so on. It's all people, psychologists have discussed this, how to analyze this for a long time, and we all agree this plot is not the right thing, but it's the thing you might have seen. So what we typically be doing is then we run a big computational model on the Dunning-Kruger effect, and we took the computational approach actually from a Nature Human Behavior paper and also compared this to their data set. And then we compared kind of their control group, so they didn't have an AI model, to our AI group. And what we could see is, while they have this nice Dunning-Kruger shaped pattern where the low performers relatively overestimate themselves, we find a round pattern. What this means is everybody overestimates themselves. So even the very smart ones, all in the sample, they also overestimate their performance. And this gave me then a pause to actually think about, okay, what does it mean then to use AI effectively? So we turned also to our other measures that we had in the study, and it's kind of large scale. We had more than two samples of 250 people, so we could run good correlations on this. So we also gave people in this study an AI literacy test. AI literacy is all about kind of self-reporting. So those tests are about self-reporting, whether you use AI critically, whether you know about how AI systems work, and so on. And what we figured is something very counterintuitive, namely not that people that are very AI literate, that they actually perform better, but we found that those are actually the people that are very overconfident in their judgments when they use AI systems, and also that they are worse off in actually judging their own performance when using the AI system. So self-report of AI literacy is probably doing something else. And this is something that we're now on to figure out what would real AI literacy even be. That's kind of very, very problematic thing. And and we've tried, so this is now the snail that's been used for a lot of people, but we've also tried a lot of other measures, and it all looks like this a little bit. AI literacy is probably something to measure confidence in your abilities to use AI, and it doesn't predict your real performance. So my speculation is, and how much time do I have still? 10 minutes. Okay, perfect. Then we are very much on track. So my speculation is, and I invite you also to discuss this with me, and I think we're all using those systems. So my speculation, and this is not my theory, if you steal it, please ask me to be a co-author. Maybe, yeah, or cite me, that's also enough. Anyway, so I think, and I talked about this with some people who do a lot of work on metacognition here at UCL. That's why I'm also happy here. We came to the conclusion that AI hype, kind of this hype that we see, brings just a very strong prior in our confidence about the AI systems and our interactions with it. If you think it kind of Bayesian way, right? Strong prior. And our interactions with AI systems are manipulated already by this prior, how we approach them. And then it's very hard to update this prior and really understand how this changes. And that's what we're suggesting. And then there's the second thing that's happening when we are using AI. We're offloading a lot of cognition to it, right? We're just saying, do the task for me. And what happens if we offload a task to some other agent? If I now say, Martin, please write the paper for me, I lose my ability to say how confident I am in this. And that's the other thing. So the offloading then also brings us to be worse in estimating our own confidence, because it's much noisier to think about how well Martin did as compared to thinking of how I did in the task. So and Martin is a black box for me, like an AI model. So this combination of AI hype and offloading then brings this problem of that we cannot monitor really our performance because it's so noisy what we are monitoring. So in effective metacognition, you would be looking at how you interact with the system, right? You would monitor, I'm not so sure about this answer. Maybe I should take a second step and maybe ask the LLM to explain itself, or second guess stuff. But what you mostly see in all those human AI interaction studies and reasoning studies with AI, people only use one prompt. They just give in the question, they take the answer, and they leave. Even if we incentivize them to get more money, that when they perform right, or when they are metacognitively correct, so estimating their own performance correctly. So there's no way really to break this cycle. I think if we do not figure out how to solve cognitive offloading and the strong prior the AI hype. So this kind of mixes onto each other. And I think that until we have figured this out, there's not going to be much updating happening when we interact with AI systems. We cannot learn much from it if you think it's always right. And this brings me already to a little bit of a promotion. So I was very happy recently to get a bunch of money for figuring this out, this metacognition thing in human AI interaction. And I have this ERC starting grant right now on this topic, and I want to solve this with design methods for human AI interaction and also computational modeling of the processes of gaining confidence in human AI interaction. I'm looking for research assistants, PhD researchers, postdocs, and anyone who can help me with this. So if you know anyone, then send them my way to help out. The grant is somewhere here. You can actually download it and look at it. So if you know anybody who's interested, that would be great. So I want to stop at one note. So what I'm sure right now, even when we are very much in the early phase of understanding human AI interaction from this metacognitive angle, I think we should already be thinking of how to design human AI interaction for metacognition, for being accurate and aware of the interactions that we have with the systems. Let it be in cognitive performance context, but also in other contexts like education, healthcare, and so on. We need to be aware how we interact and how we use the systems. And they're not doing a good job right now at helping us there. They do not have provenance, so any information how we use this built in. They do not have any guidance on this. And I think that's something that we need to do, so that we design human AI interaction for metacognition, for being, in my case, cognitively more effective, so making things more right, instead of just making more things faster and being more efficient. And with this, I want to close this a little bit earlier, but I'm very happy to talk about the prospect of designing stuff for metacognition, about the placebo effect of AI and what it will mean for human AI evaluation. Yeah, I'm very happy to be here because there are so many bright minds who also are thinking about this.
Thank you very much. So I'm the black box now and also bringing the question stone. So if you have any questions so far. Also, please introduce yourselves.
Hi, Enrico Costanza from UCLIC. Thank you. Very inspiring talk. I knew the placebo effect paper. I didn't much like the name and the person. At some point, you mentioned that self-reported AI literacy gave you sort of an even worse effect.
Yeah.
Why is that surprising? Isn't self-reported AI literacy very close to sort of how much you believe in AI hype? Normally, I tend to prefer to ask people sort of probing questions, because my experience is that if you have a PhD in machine learning, you probably think that you don't know as much as you would like to know and as much as your professor knows. While if you just read a popular science article about machine learning, you think, I now know machine learning and understand it perfectly, I'm an expert.
Yeah, so I was not thinking that way before. I was very kind of thinking those that are, I didn't think self-report would bias the whole thing so much. We first really just wanted to control for AI literacy to figure out, okay, it's maybe driving the effect, and maybe is this what makes people perform better when they're AI literate. That's also what the EU AI Act says, kind of, we need to bring people to be AI literate so that they use AI more effectively, efficiently, and also. But now, after this study, I obviously don't believe in this. But I needed longer for this.
But sorry, just to make sure that we're on the same page.
Yeah.
I don't have a problem with AI literacy.
Yeah.
I have a problem with self-reported
Right.
AI literacy.
Yeah.
I do think that like
But what would be
people
what would be a
who
good test of AI literacy? I was
that is a very
if
good
you have this, then let's do that. Yeah.
yeah, let's well we have a meeting booked already, but
Yeah.
yeah, I think it would be interesting to see if your effect holds when you actually measure AI literature. We did I started thinking about this like a million years ago when I was working on wireless sensor networks.
Mm.
And we basically asked just 2 or 3 open-ended questions
Right.
from which then 2 of us coded this answer, where does it score from 1 to 5, etc., etc. So be interested to interesting to look at that.
So what my gist is that technical competency will not go very far. You can understand neural nets, right? Or you could understand, so that's AI literacy, it's very global, right? You could also have try to code GPT-2 in your Excel sheet. That's totally possible. Then then technically you understand next token prediction, I'm sure, right? But I'm also sure that there's a big illusion of knowledge happening. Like if you just see how it nicely spits out an answer and is correct more than you might still fall for this, even if you know how it technically works, right? There are engineers who say it's conscious.
Yeah,
and
the guy that got kicked out of Google.
Yeah. So I'm just saying it's like technical understanding maybe won't cut it. That's it's more about practice.
It'd be interesting to understand more. Back then, we had one question was about how much theoretical knowledge do you have of X, and how much applied knowledge you have of X. And we found that theoretical knowledge did not have an impact in task performance, but applied knowledge did.
Yeah,
So
that might be actually the I would agree with that. Yeah.
I think that also like understanding like what knowledge matters is important, because I do sometimes find myself discussing with people who think that ChatGPT is basically Gen AI, like a general AI. And they don't really seem to think about where the information comes from at all, and the fact that there's text that has been parsed and used to train the models, etc., etc. So I think that maybe that could also have an effect. I mean, I could continue talking, but I think I should give the microphone.
Yeah. But let's talk about that. I think that's kind of this applied kind of and trying stuff out and learning from it might be the way to go for AI literacy. And knowing about neural net might not be, or about kind of how a transformer works might not actually get you much further. Yeah. Anna.
So thank you for brilliant talk. Loved it. I'm wondering if you could say something about what you think the implications of your findings are for what guidance we should give people for using AI systems as part of their knowledge work tasks.
So we are now, I think what you shouldn't be doing is putting a question, getting the answer, and taking it. Right now, the interaction patterns that we have with this kind of prompt response and then probably take it is not what we should be doing. We should probably be, so what we propose in this last paper is something like you have to make sure that people understand it. So if it's really about deep knowledge work, we propose kind of this explaining back. So you get the answer, right? But you have to explain the whole thing back. Otherwise, you might not get to the next interaction with the advanced AI system. And then if your explaining back doesn't work right, then your task might be to like prompt and go deeper and depth in your knowledge. And those interaction patterns we're now trying out if they are more successful in getting you to be more metacognitively accurate in your, or more aware of your interactions, to cut it short.
No, really interesting talk. I won't do the intro again because we met an hour ago. I'm not sure how to exactly phrase the question, but I'd be curious to know how exactly when you described it as AI assisted, visually or in terms of feedback, how did that show up? So you showed the reasoning task.
Mhm.
Was it an AI chatbot? Did it say, I think it's this one because, like, or did it just make the decision for them? Because I'm just...
No, it was interactive. I can show you. So in the last one, you had a real AI on your hand. Just make sure that this comes across. It was just GPT-4, like just GPT-4 in a, oh, sorry, wrong slide, next one. It was just GPT-4 here on and you had to do one interaction, otherwise you couldn't go forward. So we made sure they used the AI system somehow. And most of the people, and we looked at the interaction patterns, we logged everything. They just used this copy button up here from the thing, put it in there, got the answer, and were right. Even if we told them, well, if you are more aware or if you perform well, then you get more money. So they just believed in the AI overlord, whatever it spat out. And we are now trying a little bit out. So maybe rewriting this output. So sometimes it's really gibberish. We're also looking at right now when we push this out, now with reasoning models being there, if they actually look at the reasoning and maybe even changing up the reasoning to that it's gibberish again, whether they detect it. But so far, what I can say from the preliminary data is nobody cares what the model's actually doing, and nobody looks at the reasoning of the model, for example. So what you actually do here on the interface part, there are also people proclaiming you can add, for example, a little bit of uncertainty. So like making the AI, so you can detect kind of in the next token prediction, when it says the result is A, B, C, D, right? You could then look at the probability of the next token to gauge some kind of confidence in A, B, C, D, right? And then people are trying to, when the confidence is very low, to say it may be B, it may be C, and when the confidence is very high of the model, to say it is for sure A or B. But even that will not solve this big of an effect, that people think they had 20 out of 20 right when actually they had like 5 or 6 or 10 things right only. So that's kind of, I think we can get a little bit better, but this might be very incremental to just change the phrasing or the interface that slightly. I think we fundamentally need to hammer down the new interaction with it and maybe make it a little bit less effective, a little bit more annoying even. But for knowledge work, I think it will be very important to make people think deeply. And we have to figure this out. Yeah. Sorry for the...
Can I follow up on that?
Yeah.
So I just think it's particularly interesting because we're talking about confidence, and you pointed out that the speculation is around the point of confidence as well. But you sort of brought up the example, if you ask Martin to do something and he goes write something, you're kind of taking the point that you are getting feedback. And if no matter if it says it may be this or maybe that, as far as I know, as far as I recognize, most LLMs, the text that they generate is going to be relatively direct and confident in the first place. Martin comes back to me and says, yeah, but I'm not sure if this is good.
You can force them to be like, to be less confident, or you can, that's kind of what people are doing now. They basically register kind of the mathematical confidence of the prediction of the next token, and then rewrite the text of the LLM to be less confident. So that's just a training issue of the reinforcement learning to make it less kind of, how what's the word right now? Sycophancy. That's the new trend word, to make it less so. That's just an engineering problem. But it will get us a little bit better, but I don't think that we get the substantial effect that we actually are looking into if it comes, for example, to knowledge work, where we need to go deeper into knowledge. Just if the LLM's like, I'm unsure, then you're like, yeah, but you have all the training data of the world, so you might still trust it because your prior of the interactions is so high. That's my gist on that. Yeah.
I'm still wondering what the point of confidence, if you're trying to incorporate the confidence of the model in its own answer as a point, then necessarily I see how you are kind of suggesting that the user is leapfrogging the confidence of what the response is, and just the fact that it has confidence in the LLM as well. I'm thinking more so, the interaction is very similar to how you would communicate with someone else, because you're getting a verbal response or a linguistic response. But then you have the metacognition of how the other person's going to think about the thing that they are thinking about in the first place. So Martin coming back and saying, I'm not sure about this answer, is me thinking, okay, but why does Martin think he's not sure about this answer? As opposed to here, what you're saying is, oh, there's a statistical thing that there's a linguistic next token.
Yeah.
Like that in itself is removing, I think, the concept of the metacognition from the confidence.
Yeah.
And I don't know if maybe that's a different model. I'm just more curious in the fact, again, like how are you actually representing this? I feel like it seems to me that there's still more of a compounding factor on how that affects people's confidence, especially if it's a very long text and it's very convincing. Even if it's maybe, it's the fact that it is inevitably going to be an incredibly confident thing. And it just reminds me of fake news as like a part of confidence in LLMs as well. Again, I might be jumping into a different space. I'm just curious to understand what you mean by confidence in the system versus confidence in the confidence of the system and so on.
Yeah, so there's kind of like, so we can stack layers and layers of metacognition on top of each other. Kind of, I could have confidence of Martin using the LLM right and so on. Then we get levels of layers and so on. And we can think about our own thinking and so on. So that's kind of this kind of stacking, and kind of in every step, obviously you create noise because you're an estimator of some cognitive process. And if I have to estimate the LLM's ability to solve the task, right, then I'm already kind of in the second person context, like you say, right? It's like I have to gauge Martin's confidence in this, and then I have to metacognitively either think of how confident is he from his body signals or from his voice or from his writing, or even from his how he performed the task, right? How he was scribbling on the paper to solve this weird math problem. And this kind of second person approach and thinking about this, it helps us think about what's happening, right? But I don't think we can just take our interaction patterns that we have from kind of the how I would make sure that Martin is correct in what he's writing. I don't think that's really what will get us really quickly to a solution there, because Martin would be expressing his confidence because he cares about our relationship and so on. And the LLM doesn't care about you. It cares about you buying the plus subscription. Yeah. That's, yeah, I see your point. Yeah. Yeah.
No, it's an interesting subject. Maybe I'll find you if you want to talk about it.
Yeah.
Okay, I'm now the very socially anxious AI now. Thank you very much. I think we have to wrap up. So before I was turned into a black box, we have here a dark purple blue box for you as a small thank you that you visited us. And so first of all, big applause for Robin.
Thank you for having me. I'm happy to discuss anything. Yeah, and I'm still there until Friday.
Exactly. So Robin is still around. So if you can't find him, you can reach out to me and then make sure that you find him. Also, we're going out for a cheeky pint around between now and 5. It's like, I don't know, it's like, what are the preferences? Should we head out in half an hour or an hour? What are the preferences here? 4:30? Sounds like a plan?
Sounds good.
Okay, so if you want to join us, and please join us, because in vino veritas, the Latin speakers showing up here. Join us, and we're going to Birkbeck. I'll try to collect everybody at the hub. So yeah, and please come again. Thank you very much, Robin.
Thanks for having me. And thanks for the present. Oh, it's a cup. I love cups. Yeah, that's great.
It's like a small reminder of us.